Hello friends, welcome to the course Essentials of Data Science with R Software 2, where we are trying to learn the topics of sampling theory and linear regression analysis. In this module, we are going to continue with the sampling theory with R Software, and we will continue with the chapter where we are trying to learn the sampling theory for proportions and percentages now with R Software. So, in the last two lectures, we considered the simple random sampling for qualitative variables, and we had defined the sample proportion as an estimator for population proportion. We found the standard errors of sample proportion, and in this lecture I am going to show you that how you can implement the estimation of population proportion as well as finding out the standard errors when the samples have been drawn by simple random sampling with replacement and without replacement. So, in order to show you all these things on the R software, first I would try to create a population. Once you create a population yourself, then you know what is happening in the population, and then you will implement all the tools whatever we have developed in the last lecture on the R software. And when you are trying to implement the computation of proportions in the R software, you have to remember first one thing that is very important in the case of proportion and percentages. Whatever observations you are getting, they are going to be in terms of yes, no, agree, disagree, etc. So, they will be converted into 0 and 1s. Once you convert into 0 and 1s, then we need to convert that data into a numeric vector. Why? Because I will show you that the population will be converted at some intermediate steps in the terminologies of true and false. So, those true and false will be converted into the real population, but in practice this may not happen. In practice you will be getting a data in some good, bad, yes, no. So, you have to just decide once that what are your indicators, whether good is represented by 1 or 0, bad is represented by 1 or 0. So, this is what you have to keep in mind. So, in the first part of the lecture I will try to create a population, and then I will try to implement all the expression that we have developed in the last lecture. So, let us begin our lecture from this slide. So, we already have learned that whenever we have a qualitative variable, the observations on the qualitative variable are converted in a quantitative variable which we had denoted by y, and y was defined in such a way such that y takes value 1 and 0, and 1 will indicate the units which belong to the class C, and 0 will indicate the unit which belongs to the complementary of C class, which is indicated by C star. So, now for each of the unit in the population y1, y2, y capital N, now I can define here y equal to 1 if the ith unit belongs to C, and y equal to 0 if ith unit belongs to C star. Okay. So, now first we try to create the population. So, in order to define the sampling units in the population vector, which we are going to denote by x, which is further going to be classified into two classes. So, the values will be indicated by 0 and 1, and this can be obtained using the command as dot numeric, and inside the parenthesis you have to give the population vector or the data vector. So, let me try to take an example first. Suppose I consider a population which is simply consisting of the numbers 1, 2, 3, 4 up to 20, right, and somewhere here it will be 10 and then 11 and then 20. So, what I try to do here, that I try to divide these numbers 1 to 10 say into one class, and we denote it by 0, and all the values 11, 12, 13, 14 up to 20, they are assigned to another class, complementary class, and they will be denoted by here 1. Yeah, you can take reverse also, means you can denote the first group by 1 and second group by 0 also, that is your choice. Okay, so here a data vector y pop means population of y as 1 to 20, and you can see here these are my population values, and this is the screenshot here. So, that is simple, straightforward. Now, I need to convert this data into two classes. So, I try to find out the population values which are greater than 10, and I try to assign all such values or the outcome of this command y pop is greater than 10 in a new vector y indicator. You can recall that when we did some basic fundamental of the R software, then we had learnt that what is the meaning of some data vector x greater than 10 or x greater than 20. So, that was a logical operator. So, I am trying to use here a logical operation. So, what will happen here, that all the values in the y population, which is y pop, the numerical values from 1 to 20, out of those things, first 10 values, that means number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they will be denoted as false. So, this first value is 1, second value is 2, third false is 3, and so on, and the last false here is 10. And the remaining values which are going from 11 to 20, they will be denoted by here true, because what it is trying to say, when I say y pop is greater than 10, that means all the values which are greater than 10, this condition is true. So, this is what is indicated by here these true. So, this true will be indicated value 11, the second value will be 12, third value will be 13, and the last value will be here 20. But this outcome, what is obtained from the y indicator, this is in terms of true and false. So, I need to convert it into a numerical vector. So, in order to convert it into a numerical vector, we will use here a command as numeric, as dot numeric. So, the command as dot numeric will change false into 0 and true into 1. So, you can see here, once I try to operate this command on this data vector y indicator that we have obtained here, all the values which are here false, they will become here 0, right, and whatever are the values which I had obtained under true, they are converted here and into ones, and I try to denote these values as y prop. So, y prop is my resulting population, the population in which first 10 values are 0 and say remaining 10 values are 1. So, that may indicate that okay, these are the people who said no to the proposal, and these are the people who said yes to the proposal, or this is a group of students which are male, this is the group of students which are female, and so on. So, now my population is with us now, and we would like to draw here a sample, and this is here you can see this is the screenshot. So, if you try to do it yourself on the R console, you will get this one, although I will try to do it at a later stage. Now, what I have explained you in the last lecture, that we will use simple random sampling to draw a sample from this population. So, my population here is y prop consisting of 10 zeros and 10 ones. So, from there I would try to obtain a sample. So, in order to obtain the sample, I will be using the same command which I use in the case of simple random sampling, which is sample, SAMPLE, and then there will be an option that replace is equal to true or false, that will indicate whether we want the sample with replacement or without replacement. So, at this stage, first we try to consider the simple random sampling without replacement. Right. So, I try to use the same command that we discussed earlier, sample, then the population from where we would like to sample, sample size here n. So, I am trying to choose here sample of size n, that means from the population y prop, and since I want SRS WOR, so I am using here replace is equal to false, that means please do not replace the value. Now, once I try to execute this command on the R console, here I am getting this sample 10011, and similarly if you try to repeat this sample here, you will get here another sample 10100. So, definitely this is a random sample. So, means every time you try to repeat this command, you will get a different sample. Right. So, first let me try to show you this thing on the R console. Right. Okay. So, you can see here that first I try to define here the population R console. So, you can see here this is your population, the number from 1 to 20. Next command in this I am trying to use here that try to choose all those values from this population which are greater than 10. So, I try to do it here, and you see here I get y indicator S like this. This is the same command which you have obtained here. And now, I try to convert this thing into numerical vector. So, I try to convert these values into numerical vector. So, you can see here y prop. Okay. Now, when I try to draw the sample from here, so I try to use the command sample and I try to draw a sample of size 5. So, you can see here this is the sample y proportion without replacement. Right. And if you try to repeat this command, you will get here a different sample. So, okay, so that is the reason that whatever results I have presented here, when you try to execute it on the R console, they may not exactly match, because every time I draw the sample, that is going to be different, and in this slide whatever results I have presented, they are based on the sample which I drawn when I was trying to prepare these slides. And one thing, as I said earlier, you can now notice here that in this sample also, if you just try to look at the sample and if you do not consider the population value you do not know, then by looking at this 10100, you cannot identify whether these ones 1 1 they are corresponding to which of the values out of 11, 12 up to 20. You cannot identify by looking at the value that this one is corresponding to which of the value. For that you have to do something more. Right. If you remember, we had done a similar example where we took the height of the students and we did everything. So, you need to do a little bit more computation in the R using your knowledge of R. Right. So, please do not get confused now. So, this is my screenshot, and now, I fix my sample here, that my sample here is like this 10100. So, obviously, if you want to estimate the population proportion here, population proportion, well, in practice that will be unknown to you, but in this case this is 5 upon 10, which is 1 upon 2. And now from the sample you would like to estimate the value of capital P. So, this I am estimating here as a P, that is the number of ones and zeros. So, you can see here 1, the number of ones here are 2 divided by here 5. So, this is equal to here 0.4 and this is the value of P, right. And what is here Q? Q either you can obtain by number of zeros, which is here 3 divided by 5, or this is also 1 minus 0.4, which is here 0.6. So, you can see here when you are trying to compute here the mean of this sample data, this is trying to give you some 1 plus 0 plus 1 plus 0 plus 0 divided by 5. So, this comes out to be 2 upon 5, which is 0.4. So, you can say here that the population estimate here is 0.4, and you can see since you are using a good estimator. So, this value is very close to 0.5, and even if you try to take some more samples, I will show you when I come to the R console that this value will not change much, because you are using an estimator with good statistical properties. Now, we already had obtained the simple random, the variance of y bar under simple random sampling under WOR. So, this expression was n minus n upon n capital S square, and estimate was small s square, and we know that this s square is being computed in the R by the command variance. So, what I can do, I can write here this quantity, which is here n minus n upon n, and this will give you a small s square, and which is the same quantity say n upon n minus 1 times PQ, as we discussed in the earlier lecture, right. So, and if you want to find out the standard error, so you simply have to take the positive square root of this quantity, that is the variance of P. So, here I am trying to write down the square root of the variance of here P, which is here like this. So, now you have seen that from the given sample we can compute the variance of sample proportion as well as the standard error. So, since we have taken a population of size here 20, so capital N is here 20, small n is sample size 5. So, I can compute this quantity, this variance of here P, and the data what we have considered, it is stored in the data vector y prop WOR. And if I want to find out the standard error, I simply have to take the positive square root of this value of variance. So, if you try to execute this command on the R console, we get here the variance of P as 18 under SRS WOR. And if you want to find out the standard error, so you simply have to take the square root of this expression here, and you can see that this quantity comes out to be 4.24, right. So, this is how you can see finding out the estimate of variance or standard error is not difficult at all. And here this is the screenshot, whatever I have presented here. Okay. So, now I come to the second case, SRS WR. So, I try to consider the same population and I try to draw here a sample, but WR. So, I will use the same command sample, and the population is here the same y prop, sample size is the same as n is equal to 5, and since we are going for SRS WR, so I will use here the option replace is equal to true. And when I try to execute this command on the R console, I have here a sample 00101, and now I will try to explain you here, and I would like to draw your attention. By looking at this sample, you cannot identify also that whether this sample is SRS WR or WOR, because there are only two values, 0 and 1. Right, and also you don't know that this 0 and 1 correspond to which of the unit population unless and until you try to do it in a more systematic way using the command from data frames. Okay, similarly, if you try to repeat this command, and you will get here another sample which is different from the first sample, and similarly if you try to increase the sample size also, sample size is now here 8, then executing the same command we get here a sample of size 8, and such more samples can be drawn. So I will now try to fix my sample, and I will try to do some computation, and but when I go to the R console to demonstrate all this computation, my result will be varying from the result which I have represented in my slides, because as said earlier, these results were obtained from the sample which was drawn when I was trying to create these slides. So this is here the screenshot. So now I draw a sample by SRS WR, and I fix it here as a 10110. So this is my Y prop WR, means Y proportion with replacement. And now from here we know that in order to estimate the population proportion, the sample proportion is an unbiased estimator of the population proportion, so we use it. So sample proportion is simply the sample mean of the values in the sample, which is 1 plus 0 plus 1 plus 1 plus 0 divided by 5, and this comes out to be here 3 upon 5, which is 0.6, and Q will become obviously here 1 minus 0.6 is equal to 0.4. So you can see here that the estimate of population proportion comes out to be 0.6, and it is not difficult to find. You simply have to operate the mean command. And similarly, now we try to find out the estimate of variance. So you may recall that under SRS WR, the variance of sample mean is n minus 1 upon nn capital S square, and if you try to replace capital S square by small s square, which can be estimated in R using the command VAR, variance. So this is how I can obtain the estimate of variance, and if I want to find out the standard error of the sample proportion under SRS WR, then I have to simply take the square root of this quantity. So that is what I am writing here. This is the estimate of the variance, and here I am trying to take the positive square root of the variance of P. Now I try to execute these things on the sample value that we have obtained. So we have here capital n equal to 20, small n equal to 5, and using the command for the variance of sample proportion in the data Y prop WR, it comes out to be 22.8. And if you try to take the square root of this quantity, this will give you standard error of sample proportion small p, which is here like this. Right. So you can see here it is not difficult to find out these things over here. And this is the screenshot of the result which I have presented here. And now I will try to come to the R console, and I will try to show you all the things. So I already have created the sample, but I will try to use the same command over here. So I will try to use the sample, and then now I try to find out its mean as well as variance and standard error. Right. Okay. So you can see here that I already had obtained the sample. So my sample here is same Y prop WOR. You can see. Sorry, this is Y prop WOR, small letters. Yeah. So I would try to operate the commands over this thing. So if I want to find out the population estimator, that is sample proportion to estimate the population proportion. So, I simply have to find out the mean of these values. So, you can see here there are 3 values here which are 1. So, 1 plus 1 plus 1 3 upon 5 which is 0.6. And if I try to find out the variance, so this is the variance of sample proportion. This will be the data vector here is y prop WOR, and but you will see here you will make a you will get here the value capital 18. Why? Because I already had, I can show you that I already had entered the value of here capital N which was 20 and small n was here 5. Right. Okay. And if you want to find out the standard error, so you simply have to take the square root of this quantity, which comes out to be 4.24. So, now I come to the case of simple random sampling with replacement. So, you see here I try to first generate the sample here, and I have cleared my screen so that you can see it clearly. You can see it, this sample I have denoted y prop under WR. You can see here this is 01110, the sample of size 5, and if I try to repeat this thing, this is again 00000. Well, you see this is possible because the probability is not 0, but we know that this is not a very nice sample. So, let me try to generate one more sample, and you can see here this is like here 00101. Now, if you want to estimate the population proportion, you simply have to find out the mean of this sample, which is 0.4, and obviously there are 2 units out of 5 which are 1. So, this is 0.4, and similarly if you want to find out the variance, the command for the variance here is, so I copy the command here, and if I execute it, this is 22.8, and if you want to find out the standard error, so you simply have to take its square root, and this will come out to be like this 4.77. Right. So, you can see that it is not difficult to compute this thing. Right. So, now I have shown you that how you can estimate the population proportion, its standard error in case of the simple random sampling for qualitative variable. And if you want to compute the confidence interval, I had explained you in more detail, means I had explained you all the steps that how are you going to compute z alpha by 2 using the command qnorm. And so, I am sure that it is not difficult at all for you to write down the one line expression for finding out the lower and upper limits of the confidence interval. So, that I will leave up to you. I already have shown you that how you can compute small p, how you can estimate the variance of small p, and in order to find out the value of z alpha by 2, you have to simply find out the percentile, which can be obtained for normal 0-1 distribution using the command qnorm, qnorm, and you can obtain the required confidence interval. But after that, you also have to make the continuity correction by adding and subtracting 1 by 2. So, now I will stop here. I have given you all the details that how you can draw the simple random sample for a qualitative variable, for a quantitative variable, how to estimate the population mean, population proportion, how to find out the standard error of the sample mean or the sample proportion, how to construct the confidence interval when sigma square is known, when sigma square is unknown, and both type of confidence interval in the case of quantitative variable, the confidence limits are exact, whereas in the case of qualitative variable, the confidence limits are say approximate, because that is based on an approximate normal 0 1 distribution. And you also have seen it is not difficult at all to compute them or to estimate them using the R software. So now you can say the journey starts here for you. You can imagine that there is some online shopping site which has gathered a population of millions and billions of observations, and they want to know something. Without going into all the observation, because they can challenge the computational power or the structure or the architecture of the computer, possibly they may not handle that many observations. This sampling gives you a solution that you need not to go for all the values, but you simply have to choose a sample of reasonable size and then compute everything whatever you wanted to compute for the entire population just on the basis of a small sample. So now this is your turn. Think about it. Think about the areas where you can use it. And after that, who says becoming the data scientist is difficult? Those who say they don't know what is statistics. So you try to learn, and on the next lecture I will come up with a new topic. Till then, goodbye.